And hi, Sebastian. And actually, this is one of the
Hello.
more exciting companies, I think, in our program. We followed the developments at Skeleton for quite a number of years, and really, really fantastic supercapacitor technology. So the stage is yours. You have about 20 minutes. I think at the 18-minute mark, I will give you a notice, and then we go into Q&A. And just before you go, a notice to the audience today, the format of following the talks is a little bit different. So the talks will switch automatically to the next one. So don't worry, this you just auto follow the presentations. So yeah, good luck.
Yeah, great. Thanks a lot for the introduction. So today I want to talk to you a little bit about high power requirements, how to address them, and what Skeleton does, which is supercapacitors and high power super batteries. But first of all, let's start from the beginning. Why do we do what we actually do? Is that the key enabler for sustainable energy today is energy storage. But it's energy storage that is not only based on lithium ion batteries, but also energy storage that goes beyond that. Why that? Because lithium ion batteries are not a silver bullet. We have seen this in many occasions. They sometimes don't have enough power, sometimes don't have enough safety, sometimes don't have enough lifetime. So that is where we come in with our technology, which is non-lithium based, supercapacitors, and high power, and actually lithium containing super batteries. And we come in from a material side where we actually bring a novel carbon material into energy storage. But let's first talk about what are supercapacitors. So supercapacitors are really high power energy storage devices. They use an electric field to store energy. That's the difference to lithium ion batteries, which store energy in the electrochemical interactions between anode and lithium ions, for example, or sodium ions. And supercapacitors don't do that. So they don't have an electrochemical interaction between the electrode and some ion, but they store energy in an electric field, which is just charge separation. So they have a layer of ions on the surface of an electrode, and that's all there is to it. That limits the energy density quite a bit. So energy density-wise, supercapacitors are much lower than lithium-ion batteries, and that's a factor around 30, 25 lower. But they have much higher power, so around 100 times higher power density than lithium-ion batteries. And for the same reason, if a charge is just present on the surface and you don't need to drag it out of a material, you don't have a lot of ion movement associated with this charge or discharge, then of course you can charge and discharge much faster. Supercapacitors also can be charged for a lot more times than lithium-ion batteries before reaching the end of life. So easily 1 million, 2 million cycles are possible with supercapacitors, and they are inherently safe. There's no thermal runaway with supercapacitors. You can fully charge them, punch a nail through them, crush them, overheat them, and will not have a fire or an explosion. Also, supercapacitors don't use any nickel, any cobalt, any lithium, and are easily recycled. Only metal content is actually aluminum. So you can also produce supercapacitors with purely European resources because you have carbon, aluminum, an organic electrolyte, all these things you can get from Europe. So how do they work? Supercapacitors work, as I already mentioned, by separating charges. So if you have an electrolyte, which means any liquid with ions dissolved in it, and that electrolyte is in contact with an electrode, in this case here on the slide, a positively charged electrode, then of course the ions will move to that electrode and they will form a layer. This is called the electrochemical double layer, which basically means that you have a mini capacitor there because you have a positive charge right next to a negative charge. They are separated, they don't combine. So that is the definition of a capacitor, two charges separated from each other. And you have this on the other side of the supercapacitor device as well. So you basically have two capacitors, each electrode is one, on each side, and they're separated by the electrolyte. That means that supercapacitors gain energy by increasing the electrode surface and by decreasing the distance between the electrode and the ion. Yeah, so if you get the ion to stick better to the electrode surface, then you increase the capacitance. And if you have more electrode surface, you increase the capacitance. That's different to